Okay, so we got a couple of things we want to talk about. First thing is we've got that second test coming up. So I just want to go over some issues with that. And then it looks like we're potentially looking at rain again. I don't know just what's going on here with this rain, but that's not helping us. So we still need to get that utility location lab in. And so we'll kind of see. Let's take a look at the test first. I did open up this folder. Um, So I want to kind of review for that, but primarily this will be an online test. Okay, so it'll be a little different than doing it face to face. The only difference is that you'll have to deal with the online issue. If you've never done that before, it's a little intimidating for some people, but it shouldn't be that big of a deal. I will give you plenty of time, so you'll have a 5-hour time block. But the one thing about that, you won't. It should not take you 5 hours. But the idea being is that it'll give you enough time so that you can feel comfortable with that and interacting with Blackboard. Okay. I do expect you to, enter some of your answers through Blackboard because it's kind of an accountability issue for me. But you'll have the time frame anywhere from Friday morning up until the evening, Sunday evening, to take this test. So you can take it whenever you want, but once you start it, make sure that you don't interrupt that time, because once you stop, you're out. Okay. So just make sure that you set aside enough time to be able to take it. Like I said, I really don't anticipate it taking 5 hours. Okay. Do you have questions, somebody? After you take the test and submit what you need to through Blackboard, then I do expect you to follow up that with solutions. Okay, so you need copies of that sent to me. Now, there's different ways you can do that. If you have a way to create a PDF file or scanner at home, that's the best. Okay, PDF files work the best for me. But if you don't have that capability, you can take pictures with your phone. Just make sure that I can read them, because if you can't see them or read the numbers, I can't read them either. Okay, so I get people that'll take them at real weird angles and whatnot, and that doesn't help me. Okay, and then of course that means you have to send those via email to me. So one PDF file is a lot better than like 6 different photo pages or whatever it takes. Okay, but I'll accept either or. That's not a big deal. I know everybody doesn't have scanner capabilities, so that's not a problem. Okay, so the test will be over. It'll be over the material. It's probably 7, 8, 9 weeks, actually, not 6, 7, 8. Okay, because of the way we've done it. But we'll take a look at that today just to make sure everybody's good with that. So do make sure that you have your books available, that you have a good stable internet connection. That you have a good working calculator. You might want some additional notebook paper. Straight edge is helpful. Okay, so those are all going to be good things. All right. So does anybody have any questions about that specific aspect of the test? And we'll start to delve into the different areas of it. Any questions on that? No questions? Has anybody done a test like this through Blackboard before?
This would be my first time.
Okay, so like I said, Jake, it's a little bit intimidating at first if you've never done it. Okay, so just what I want to do is just reassure you is that number one, I will be, if something really major happens, send me an email, because sometimes people get locked out. They'll log on and get locked out right away. Send me an email, and what I have to do is reset the test for you. That's not a big deal. Okay, but do allow yourself enough time. I get a lot of people that will do this, like they'll start taking the test like about 11 o'clock at Sunday night. That's not a good thing to do. Okay, actually, if you start the test before midnight, you can stay into it, but I would prefer that you just probably try to get it done before that time frame. Okay, but again, I don't think that you'll have a problem, anybody. But like I said, it can be a little bit intimidating. So just kind of be aware that it's timed too. So it'll time out on you, but it does give you time warnings while you're doing it. And like I said, 5 hours, if you can't do the test in 5 hours, you'll never be able to do it in 50. Okay. So it really shouldn't take you I would guess most people would be done in 2 hours max. Okay, maximum time frame. All right, anybody else questions before we start to delve into some material specifically?
So we would have the test, we'd be able to print it out.
Yes. So here, let me show you because you see this little icon here that says test? Can you see that? Okay. So when I make the test available, that'll be active. And what you would do is you just click on that at that point right there, and then it will take you into the test, okay? And so I don't know if I can do this. It'll do this, it'll give you instructions. You see that? Same instructions that you already saw. And you're not beginning the test at this point. This is just saying, okay, I'm checking it out, okay? Once you hit begin right there, then the test starts, okay? And inside of that will be a PDF document that you click on and you can print that out, okay? Does that help?
Yeah, it's perfect. Thank you.
Okay, but don't go backwards or don't interrupt the situation, because what will happen is that will probably submit your test at that point, and once you submitted, you can't go back. You can't. This will not be active once you've entered it. Okay. Now entering it like I just did here, that's no problem. Okay. If I hit cancel, it's no problem. But once I hit begin, it's live. Okay. So just make sure before you take that test and before you hit begin, you're ready with everything. Okay. And like I said, if something happens to you right away, send me an email. I'm going to be in and out on Saturday. Saturday morning, I do have a class. Okay, so I won't be available until the afternoon on Saturday. But I will be monitoring my email, so I have to reset that if something's an issue. Okay, we'll work it out. Okay, I'm not going to leave you guys high and dry. All right. Anybody else questions? Okay, so the test will be a similar format to that test. First test, it's going to be problem type stuff, solving based on the kind of stuff that we got into. We got sewer layout. I know we haven't done that yet, but we talked about that last week. So I'll go over some issues like that with that. And I'm hoping we can get to that on Thursday. And then the building layout, and then the other one was just dealing with general layout where we had taping corrections and those kind of things. Okay. So let's see if there's any questions specific to, I can go to some of these weeks. Let me see. Building location. Let me see about this one here. All right, so things would be dealing with differential leveling, profile leveling, trig leveling, steel taping corrections. Let's take a look. I'd like to take a look at some of those problems. Anybody have one in particular they'd like to look at?
I had just a general question.
Yes.
If the problem included improper length of tape and a temperature correction,
Okay.
I was solving for the improper length of tape and then using that length and then adding that to the temperature correction. Is that correct?
No. What you usually do is you solve each correction separately using the recorded length. And then you apply the corrections in mass by just adding them together, okay? So let me see if I can pull a problem up for you and then we'll do that. How's that sound?
Okay, that sounds good.
Okay, let me figure out something here. Give me a sec. I mean, you can do it the way you were talking about it, but usually you get things wrong if you're not doing them quite the way you should. So, I'm gonna make something up here, okay? And then we'll take a look at it. All right, so let's see. Can everybody see my whiteboard here?
Yep.
Okay. So here's a typical problem, and I think I hope that this will address your issue. So let's say you're out in the field and you measured out in the field between 2 points, 250 feet, okay, with a steel tape. So now let's say that we've looked at this steel tape, we've had it calibrated, and the actual distance on the steel tape is that, okay? So that's my actual distance. Let's also assume that the temperature, when we were doing this measurement, was 30 degrees Fahrenheit, okay? So we want to know what is the true distance between points, okay? So again, we're assuming we had a fixed point here in the ground, and we had another fixed point here. So we want to know what is that distance? So let me ask you this. Is this a measurement problem or is this a layout problem? Because we have to identify that first, based on what I just showed you in that diagram. Measurement or layout?
Maybe
Layout.
measurement.
I heard two answers, and only one of them's right. So if this is fixed, if that's fixed, and that's fixed based on what I said, this becomes a measurement problem, okay, not a layout. If it was a layout problem, this would be your actual distance that you're measuring, okay? This is the distance we recorded when we were out. So we understand this. We found these 2 points in the ground, and we measured between them this distance, okay? Is everybody okay with that now?
Yeah.
Okay, so what's going on here that's causing this distance to not be exactly 250 feet? What's happening here?
The length of tape is incorrect.
Okay.
So it would be the eventual measurement would actually be off.
Okay, and what else is causing? What else is happening?
The temperature is low, so it
Right.
caused the tape to constrict, making
Okay,
it shorter.
so we have two types of things we have to deal with, this one and this one, okay? So this will address your question directly. What we're going to do is create a correction for the incorrect length, and then we're going to create a correction for the temperature, and we're going to combine them, okay? So that correction, that temperature, or this correction says it's L minus L prime divided by L prime, which we talked about what those values mean. So L is the actual distance that we have here, okay? That's the calibrated distance. L prime is your nominal distance, so that's what the tape is printed on it. That's what it means. That's what it says, okay? So it says it's 100 feet, but it's not, okay? And then we're going to multiply that by the distance we measured in the field, which we call the recorded distance. Okay, so this is going to give me, this is going to set this up for me to get the correction. So if we do this, you guys have calculators, you might want to go ahead and do this with me so you can see if you get these same numbers. Anybody get a number for me?
0.05.
Positive or negative? Positive or negative?
That would be negative.
It would be positive. See this right here? So my calculator is giving me a positive. So what that's telling me is the correction is longer. Okay, so in other words, the distance we measured is not actually 250 feet. Okay, it's actually 250.05 feet. Right? That's what that's saying. Now, we also have a temperature correction, right? So we're going to look at what that temperature correction is, and that temperature correction equation says that it is K delta T, T final minus T initial times L. What is K? Or some people use alpha. Anybody remember what that's called?
645.
Yeah, that's your coefficient of linear expansion for steel. So that's material dependent. 1, 2, 3, 4, 5, 6, 4, 5. Okay. So T final is the temperature at time of measure, which would be 30 degrees. What's your initial temperature?
68.
Yeah, if you don't know, you're going to assume room temperature is 68, okay? And we're going to multiply that also by 250. So let's see what our temperature correction comes out to be. So let's see. 30 minus 68 is going to give me a negative. So what that's going to do is that's going to give me a negative correction. So what we might see happen here is that one's going to correct the other. In fact, let's see. Give me a number. I'm having a little troubles with my calculator. Hold on a minute.
Negative 0.06.
Okay. I'll be right with you. I'll check that.
That's what I got too.
You guys agree with that? Negative 0.06? Negative 0.0. Actually, if you want to carry it out, you could call it 6.1. Sometimes I'll float them out and then round everything at the end. You guys okay with that?
Yeah, that's good.
Okay, so the true distance is equal to the measured distance. Actually, let me write this differently. The true distance is equal to the measured distance, or you might think of that as the recorded distance, what you wrote down out in the field, plus the summation of corrections, okay? So summation means I'm just going to add these guys algebraically, okay? So if we do that, what we see is we have 250 plus, we have a plus 0.05 minus 0.061. So what's happening here then? If we do that, what do we get? You guys agree with that?
Yeah.
So
Yes.
basically what happens here, which is kind of interesting, the one systematic error basically what? Canceled out the other systematic error, right? Almost, right? But it just didn't quite do it. Are you guys seeing how that works now? Jake, you asked that question initially. Does that make sense now?
Yeah, the way that I was doing it was ending up with the same result.
Okay, but you're doing a lot more work, I think,
Yeah.
because you're having to worry about the number you come up with and you apply that to the next correction, and so it's a lot simpler to just sum your corrections in one step, okay? And then you're done.
In that way, you don't have to worry about signs either.
Well, you have to still consider your signs, but you consider the signs down here in the summation, okay?
Yeah, because you take it straight from what the calculator says.
Right. Does that make sense now?
Yeah, thank you.
Okay. I just did something here. Okay. So yeah, if I get that, then I'm good to go. So this was a measurement problem. How would this change if this was a layout problem? So in other words, let's say we had to lay out exactly 250 feet. What would happen here?
Since that's what the actual length is, we would have to lay out more than that to get 250.
Yeah, because what happens is these guys swap sign in a layout, okay? So this positive goes to a negative, and this negative goes to a positive. So for a layout problem, you're laying out what? 250.01, right? See the difference? Wasn't very much in that case, because again, the one error compensates out for the other, essentially. We okay with that? Because I can pretty much guarantee you're going to be hit with a problem of this nature, okay? And it may be a layout problem, it may be a measurement problem, so you have to be reading into that, and it'll probably have more than one type of systematic error they have to handle. Okay? Is everybody okay with that?
Yep.
Good with that.
All right. No problems then? All right, let's go back and look here. That was talking about the steel taping stuff and applying corrections. Okay, so those are some things that we kind of investigated in that second lab, and I have to tell you, I'm pretty behind on my labs getting grades to you guys. It's just, I've been really, really overwhelmed. In fact, I'm still getting labs in too. So it's not just all my fault, but it's partially. Okay, so the other thing is, let's look at some leveling issues. Anybody questions about leveling, differential, profile, or trigonometric? Should we take a look at a problem or two?
We can do that.
I think it might be a good idea. Now, you guys have been doing some levels out in the field. So one of the things we're seeing is it's not as easy as it seems maybe when it looks, you know, it's not hard to do. But the thing that I think you're seeing is that if you have out in the field and you're placing the level, that's a little harder. And none of you guys are really coming out with really clean numbers yet. I've got a couple of groups that have done loops that have looped back to maybe 100th or two, but most of us are still off a couple of tenths. So in the distance that we're traveling, that's not ideal yet at this point. Okay. So so what, if I ask you theoretically, what's the difference between differential leveling and profile leveling? What's the difference? Is there a difference?
Profile leveling has side shots and differential leveling doesn't.
Correct. So basic, well, let me say this, Casey. They're both differential leveling, okay? But usually what you're doing, you absolutely said it was correct, is that when you're doing profile leveling, you've got what we call side shots, or I call them rod shots. So those are external to the loop, okay? So the biggest thing when you have that kind of stuff going on there is that you need to consider them separately, okay? Let me look at something. I'm going to make something up here. Hopefully it'll make sense. I'm going to have a, let's see, a station and a back sight and an HI and a foresight. And we're going to have our rod column and then ultimately elevation. So we're going to have a benchmark. And it's going to have, let's say, an elevation of 750. And we'll just have a couple of, I'll have a back sight here, 532. And then I'm going to just have a couple of stations here. And so we're going to have some rod shots of, let's say, 5.11, 6.02, and 5.89. So then we had a turning point, 1. This will give us a foresight now. Let's say maybe 8.28. And we'll back sight this guy. Let's say 755. And then we're going to go back to the bench. So I'm just making this up as we go. So let's say we came up with okay, so there's my loop, right? So do I have a loop first off?
Yes.
Yeah, and you can see that why.
You have the same amount of backsides and foresights.
Well, that's not always the case, because you could have a line of levels and still have the same number of backsides and foresights. Okay.
You started and ended at the same point.
Right. Now, we would normally call that like benchmark whatever, right? So let's say we have benchmark A here, because that was kind of, without saying that, we wouldn't know. But if I had this, I could still have that. Do you see, Jake, how that could happen?
Yeah.
But it's not considered a line, a loop at that. I mean, it is a loop as long as you know the elevations of these two guys, but we're going to assume it as a really truly closed loop. So we're going to start at A and end at A. How's that? Okay. But you did point out something which is really, really important. If you don't have the same number of back sights and forward sights, either in a line of levels or a loop, you did something wrong, okay? Particularly when you've got these rod shots or side shots, okay? So if you're doing this, what's the first thing we need to do here?
Add up the back sights and add up the forward sights
And why are we doing that?
to see the difference in misclosure.
Yeah, that provides the misclosure. That's correct. So what we're going to do is we're going to just sum this columns and we're going to compare them, okay? 532 plus 755. I'm coming up with 1287. You guys can verify this. 828
That's what I got.
plus 4. So we get agreement.
Yeah, and then 1295.
1295. Now, technically, this is a positive number, right? Because back sights are always considered plus sights, and these guys are considered negative. So our misclosure, if we add those guys together, let me make that, get that 5 a little bit better. Kind of a really lousy looking 5. So if we do that, if we do that, we've got, what do we get for our misclosure?
Minus 0.08.
Minus, whoops, minus, not a plus, minus 0.08 feet, okay? So that's not great. That's about an inch, okay? That's about an inch off. And what is this also telling us? That it's minus?
When you went back to your benchmark, you ended shorter than you started.
Yeah, you ended lower, right? You ended lower. If we were plus, we would be ending higher, okay? So what we're going to do now, we're going to actually do the loop itself and see if that isn't true, okay? So we're going to start here. We got 750 plus the 532 gives us 755.32. Now, in the case where I have rod shots or side shots, I'm going to ignore them right now. I just want to work on the loop. So we're going to now subtract that. So we have 755.32 minus the 828. And that gets us 747.04. You guys verify that. Then plus 755. Are we okay with that so far?
Yeah.
And then this is 754.59, I think.
Yep.
And then we're going to subtract from that the 467. This gives me 749.92. So if we bring this guy down here and subtract it, it should agree both in terms of the sign and the magnitude. So I do get 0.08. These agree. So I know that I've got my loop. I know I have my math correct. Okay. Is everybody okay with that?
Yep.
Yep.
All right. So now what do we do for our rod shots? And this is where people get screwed up all the time.
You subtract them from your HI.
Okay. From which HI?
The first BMA.
Yeah, the HI they're coming from, right? So what this is saying, when you were sitting here, you shot a rod, and then you shot another rod, and you shot another rod. They're all coming from that same HI. So the easiest, if you got a storage register in your calculator, you can do that. I still haven't figured out how to do that for mine. I'm sure there's a way to do it. So then I can just do the ones separately. So I get 750.21. And then I'm going to key in again 755.32 minus minus 6.02. I get 749.30. And then we've got 755.32 minus 589. 749.43. You guys agreeing with that?
Yep.
So here's a common mistake, what people will do, and I see this on tests a lot. They'll take this number, subtract that from it, and write it there. Then they'll take that and subtract that and write it there, and then you know, keep going. And obviously it just keeps getting lower and lower, and it makes no sense. Okay. So at least you could still screw up these, but if you do your loop first, you won't have any problems. And most people, I think we're starting to understand this pretty well. Okay, but I just wanted to make sure we were good on that. Is that okay then?
Yeah.
All right. No questions on level loops, because you're probably going to see level loops. You're probably going to have to create some and use them actually to do some cut and fill information as well. Just like we did on that building. No problems then?
Yeah, I'm good.
Okay. All right, let's take a look at a trig leveling problem then. So trig leveling is kind of cool with you have a nice total station. It gives you vertical differences. So you don't have to do a lot of work. So I'm going to give you a little idea here. So we've got a piece of ground, kind of maybe looks like this. And we set a total station up here. And we have a benchmark here that say, let's say we're sitting at 656.20. And we have a point over here, and we don't know what its elevation is, okay? But by using a total station with a rod, I can shoot that distance. Actually, what I'm getting is a vertical difference. And I can take that rod and put it over here and shoot this guy, okay? So let's put some numbers here. Say the vertical difference here was plus 11.68 feet. Vertical difference here was plus 13.77 feet. Let's say that our rod is 5.62 feet. And we kept it the same over here. Okay, so how do we solve that elevation? What do we do? Well, what is this vertical difference telling me?
You subtract the 11.68 from 13.
You could do that. Why are you subtracting?
To get the difference of the two, because if we're obviously going up in elevation, and then you have the rod height, and then you can just add to the elevation over there.
Okay, you can do all that. I'm not disagreeing, but I want you to just look at this picture logically. If I draw a horizontal here, that number right there is what? 1168. Does everybody see that? That's what that means. Does everybody see that?
Yeah.
What does the plus tell me?
It's above.
Yes, we're looking uphill. We're looking uphill. So if you think about this, if you take 656.20 plus 562, that would be, if we take that 656.20 plus 5.62, that gives me an elevation of 661.82. That would be the height of what?
The rod.
The height of the reflector, right? Okay. So if this line is 661.82, what's my HI? The height of my instrument. $661.82 minus 1168. You see that?
Yeah.
So that gives me a height of instrument of 650.14. Is everybody getting those numbers?
Yeah.
Yep.
So if I'm sitting there at 650, to get this height of this reflector, I'm just going to add to it what?
The vertical difference.
Right. Which is also, it's going in the same direction. So it's a foresight. So I'm actually using the number. So I'm taking the 650.14 and adding to it the 1377. So that gets me a height of the reflector, 660.391. And then I'm going to do what with that? Subtract that rod, right?
Yeah.
So what do we come up with?
At 658.29.
Yes. So that would be the height of that guy right there. Okay. Now, the reason I went through that is so that you guys understand graphically, or from a picture standpoint, a little bit more than, but what somebody said, what we just take the 1377 and we subtract from it the 1168, right? And then we add that to the 656.20. And that gives me the same number. But I want you to know why you're doing that, okay? So it's important to understand, if you can draw a picture like this, you can always rationalize anything you're doing that helps you, okay? But you can find the difference between these two and add or subtract that accordingly. But going through the process like I did, it shows you exactly why that's doing that. Okay, is everybody okay with that?
Yep.
We did this exact problem out in the field. And, you know, I think I've talked about this very often too, is that differential leveling is still better than this. There's too many errors that can be associated with the trigonometric leveling. And like all you have to do is just bump this rod and change it to a different height, and you screwed your system up, and that can make a huge difference. So got to be really careful. What was the other thing we did when we were out? And I had you guys do when we did these vertical differences. What did I have you guys do? Do you recall? We shot it in both a vertical position and a reverse position. So in other words, we flopped the scope. Why did we do that? So we didn't just get one number at 11.68. We got several. So we might have had 11.67. Okay. Why did we do that?
To check our measurements.
Well, it's not so much a check. I mean, it is, but it's more of a redundancy in the fact that, remember, we talked about that concept of scope eccentricity. You're not going to necessarily get the exact number by just shooting it once. It's just like we shoot your distances more than once from different locations. You kind of do the same thing with vertical. So what we would do is take these guys and we'd average them, because they can be a little bit different, significantly different. Okay. And so that's a much better way of doing it. But again, you know, when you talk about trig leveling, yeah, it's got probably the most error associated with it. Okay. All right. So that was that's kind of the stuff that's you're gonna see out of this section here. Okay. So any questions on that before I move on? You guys all sound like you got it pretty well. No problems?
Yeah, I'm good.
All right. I'm assuming you're speaking for the class since no one else will. All right, building location. So we talked about layout concepts, baseline. That was the thing that we got to get, we finally got a chance to do when everybody finished up on Saturday, luckily. So one of the things I'll be talking, probably asking you questions about is cut and fill and radial stakeout, radial layout. So any questions with cut and fill? Let me go back over to this picture here.
Can you do a cut and fill problem
Oh, sure, absolutely.
off of just like a finished floor?
Yeah. Let me clean this up. Now I'm going to do it from a diagram standpoint. Okay, does that work?
Yeah, that works.
Okay, so let's assume we have a building that we're laying out. Okay, because that's kind of what you guys did. And we got this building. He's going to be sitting here in the ground. Currently though, he's not there. Okay, just understand we don't have him in there yet. Okay, so that's where it's going to be, right? And what we've got is the actual ground line might be doing something like this, okay, if we're looking at that. Okay, you guys with me? So we're kind of looking at this in profile, not really, not straight down on. Everybody okay with that? And the finished floor on this guy, let's say, is 606.22. Okay, so an engineer has spec'd out that's going to be the finished floor of that building. So you've gone out here and you've set stakes in the ground and they're at some offset. So I got one stake sitting here. He's sitting in the ground. You got a tack on him. And we ran elevations on that thing. And we did another stake offset here. Okay. And he's sitting in the ground again. So we got an elevation of this guy, let's say by differential leveling, that we figured out that this guy is sitting at 610.12, and this guy is sitting at 605.93. So we need to provide a cut or fill on these stakes. So technically, if we look at this, what you're saying is if that's a level surface of that stake, any point on this line is 610.12. Everybody agree with that?
Yeah.
Okay, so what I need to provide for somebody then is how much do I cut? What would be my cut from that line down to that finished floor? Well, that's pretty simple, right? We just take what? 606 finished floor minus 610, my stake, and the difference there is what? Get a minus 3.90. Is that what you guys are coming up with?
Yeah.
And the minus indicates what?
We need to cut it.
We need to cut. Now, if you reverse these, are you going to get the same number here? If you flip them, if you subtract 606.22 from 610, will you get 390?
Yeah.
Yeah.
But you'll get what? Positive?
Positive.
So you'll have to think, well, is that a cut or a fill? It's not that hard. Just think, if the stake's higher than the thing you're grading, then it's a cut. If the stake's lower, then it's a fill. But a lot of times, if you take the proposed object and subtract from it the stake, then you get this sign that's going to tell you whether it's cut or fill. So let's do this other one. If we use that same logic, we take 606.22 minus 605.93. What does that tell us? 606.22 minus 605, what, 93? That gives me what? A plus 0.29. So on my stake, I would write fill 0.29 for this, and this one we would write cut 3.90 for that stake. Okay, does that make sense now?
Yeah, it does.
Probably one of the easiest things you do, guys. Really, if you think about it, there's not much to it. Now, as we start to get into highways and sewers, you're going to have a lot more stakes. That's the only difference. So Let me show you, I'll show you a sewer one here in a minute because we're gonna talk about some alignment stuff issues. Okay, everybody okay on that?
Yep.
Yeah, you'll probably have to do a cut and fill problem, okay? So it's just a matter of getting your elevations of your stakes, knowing what your finished elevation is, and then just, determining whether you're above it or below it. That's all you need to think about. Okay. All right, radial stakeout is another question. There was a question on that problem too, so you're liable to have to do something like that as well on that test. Let me give you a new. So what I'm saying is we have a control mark, we have a control point here, and we have a control point here, and we have something that we need to stake out, okay? So what we would know a coordinate, coordinate, and coordinate, okay? And so we would have basically a line from here to here. And what we need to do is lay out that line to that stake. And in order to do that, I would need to know this angle, and I would need to know this distance, which I've been providing for you, okay? But in a problem like this, I'll probably just give you coordinates. Let's say 100 north, 100 east, 200 north, let's say 75 east, and we'll call this 175 north, and maybe 200 east, okay? So how would we do this? How do we get this and this from what I've just given you? Northing and easting of 0.100, northing and easting of 0.101, and northing and easting of 0.500. How do we do this?
You would
You can
need to
get
know
the-
your latitudes and departures.
Right, so what we would do is we would have to calculate this direction, and we can do that with your latitudes and departures. Do you want to go through that?
Sure.
Okay, so how do we get, I'm gonna have to write kind of tight over here, so I'm gonna put it over here. I want the latitude from what to what? If I'm occupying which point?
101.
101, so I want the latitude from 101, whoops, let's write it down right. I want the latitude from 101 to 100. So that would be the northing of 100, right? Northing of 100 minus the northing of the one I'm sitting on. So that gives me a latitude of plus 100. My departure from 101 to 100 is the easting of 175 minus the easting of 101. That's a minus 25. So what does plus 100 and minus 25 tell me?
You're going up 100 feet, and then you're going to the left 25.
Okay, or else what else you're saying is that I'm going northeast or northwest, right?
Yeah. If
Yeah,
we're
you,
saying
you
north,
said the
up.
same thing. You said the same thing in terms of distances, okay? So how do we get theta? Theta is expressed as what? The arctangent
arctangent.
of the departure over the latitude. So we have what? 25 divided by 100. Arctangent, and convert that to a degree minutes seconds. That gives me north 14 degrees, 2 minutes, and basically 10 seconds. It's not quite, it's pretty close to 11 seconds, but not quite. All right, we agree with that?
Yep.
All right, now what do we need to do?
Get the distance.
Well, okay. So how do we get a distance? Distance of
Factor in
what?
there.
Let me ask, before we calculate that, what do we need a distance of?
It would be the distance of what you would measure from 0.101 to 0.100?
No, I don't care about the distance from 100 to 101 necessarily. Now, let me say this. If you haven't been out on this site for a while and you want to make sure that these two guys are still correct, I might want to know that distance because I might want to shoot it and verify it, right? But as far as laying out this problem, doing a layout, I don't really need this distance. All I really care about is the direction. Okay.
Oh,
Right.
yeah.
So for this one though, I do need the distance. So how do we get the distance from 101 to 500?
Use
You
the
use-
Pythagorean theorem.
Okay. Fine.
And
What
you
are the
would
two
use that
what are
by,
the what are the two sides of your triangle?
that would be your latitude and departure.
There you go. So we need latitude and departure. So I don't disagree with the Pythagorean theorem, but what I need to know is what? The latitude from 500 or from what, 101 to 500, correct?
Yeah.
So that would be the northing of 500, 175, minus the northing of 100, which is 100. That gives me a plus 75, which tells me I'm looking north. The departure from 101 to 500 is going to be the easting of 500, which is 200, minus the easting of 101, which is 100. So that gives me a plus 100. So what does that tell me about my direction?
That would be in the first quadrant.
Right. In other words, northeast. Okay. So we said we need distance. So distance, now we can use a Pythagorean theorem because we're going to take 75 squared plus 100 squared, square root. 75 squared. Okay. Plus 100 squared, square root. So it looks like, what'd you guys get? I got 125 right on the nose.
Yep.
Is that what you guys got? Well,
Yep.
I couldn't have made that any easier. All right, so that tells me we have to measure, that we have to measure 125 feet, but we need to know something else. That's not going to be enough, right?
You need the bearing for that line.
Okay, so how do we get the bearing for that line?
You use the latitude and departure
Okay.
again.
All right, so arctangent of departure over latitude, departure is 100, latitude is 75. If you flip those, by the way, you're not going to get the right angle. You're going to get the angle off of the easting component, not off of the northing. So be careful. Flipping those are very common. Get that mistake all the time. So let's see what happens here. What'd you guys come up with? 53 degrees. I got 53 degrees, 7 minutes. And it looks like 48 seconds. Anybody agree with that?
Yeah, that's right.
And this would be what? Northeast. Okay, so to lay this point out, I'm sitting at 101, backsighting 100, setting zeros. What angle do I turn? And what distance do I go to set 500? What angle do I turn and what distance do I go to set 100? Well, 500.
Are you turning from north?
We are sitting, well, can you backsight north? You
Or you
set
could just
your
add
instrument
those
up.
two
Can
bearings.
you set, if I set my instrument up out in the field, can I backsight north?
No.
Well, okay, so there's your answer. Okay, so what are we backsighting?
Backsight 100.
All right, we're backsighting 100. This is my backsight right here. So I want to turn the angle. Even this picture shows me what, that I'm backsighting that and I'm going this way, right? So I need this theta guy here. These thetas, by the way, I'm using theta too much, but that's a bearing theta, okay? And this would be a bearing theta. This is the angle that we're turning, okay? So how do we get that angle? Or do we already have it?
You can add
You
those
add the
two
two.
bearings that we have.
Exactly, because if we look at this picture, north is kind of coming through here, right? So the angle this way is 14,210, and the angle this way is 53,748, correct? So let's see what we get. We get 14 degrees, 2 minutes, and 10 seconds, plus 53,748. What did you guys get? 670958. That's what I came up with. Anybody agree with that?
Yep.
So I would say instrument at 101, back sight 100, foresight 500, and I would go this distance, and I would go this angle. Okay. So that's not a hard problem, but you'll probably see something like that on the test. Watch the pitfalls are, a lot of people will inverse this angle and tell me that's the angle they turn, okay? If you were backsighting north, that would be true, but that's not going to be the case, okay? You're always going to be backsighting some control mark, something that we've talked about before. Any questions on that? I think that's a good problem. You guys understood that pretty well. No issues?
Nope.
Okay, great. Well, then the only other thing we'd be looking at on this test would be a linear alignment. Let me go back to here. So what I'm talking about is utilities. So we talked a lot about that last week, looking at three-dimensional concepts, but the one thing was the plan and profile utility concepts. So one of the things you'd be looking at would be the plan sheet. So plan sheet, what you're going to see is things like the manhole locations. Typically, it'll tell you, if I can zoom this up a little bit, things like the distance of linear feet, the diameter, and the slope. Those are going to be critical features. And what we'll be doing, if we get a chance to do this on Thursday, we're going to be setting up a sewer, staking the manhole, staking an offset, and putting control stakes along that sewer at a certain interval. Okay, so I'm going to do a real quick sample for you, and to show you what you might see, something like that. Okay, give me a sec to flip this over. So we're going to just make something up here. So I'm going to want you to guys assume right now or understand what I'm looking at. We're just going to look at one sewer line real quick. I got a manhole here, and I got a manhole here, and we've got a pipe that's between these two manholes. Okay. So this is in plan view, not in profile view. This is in plan view. So we're looking at this, like, say, down from an airplane or a drone. And the plans tell me that this sewer is 250 feet of 8-inch sanitary at, let's say, 5.5% grade. And this guy has an invert. Let's say he's at 832. We don't know this guy's invert, but we do know that it's traveling downhill like this. That's the way it's flowing. So in a problem like this, the first thing I'd want to do is determine what this guy's invert is. So who can tell me how we would do that? You have a distance and you have a slope. Okay.
You need to find out the horizontal distance.
This is the
That's-
horizontal distance. When you see that on a set of plans, remember, I've said this multiple times, when you see numbers on a set of plans, those distances are always what? horizontal, okay? So we have the horizontal information. So rethink what you're talking about there. If I know the horizontal distance, what do I really need to solve this problem?
Well, we need the vertical distance from
We need the
first
vertical
inverse to the other.
distance, right? So now think about this. If I'm saying that the flow is from this manhole to this manhole, what am I saying that this manhole is? Higher or lower than this manhole?
It'd be higher.
It'd be higher. Okay. Now that sounds stupid question, but you know, people, they go the wrong way with this. So we know that this guy has to be higher. Okay. So how do we solve that vertical difference? We have what? We have a slope and we have a horizontal distance. So what does 5.5 mean? Percent. What does that mean?
The angle at which it's going.
It means what?
The angle at which the
Correct.
pavement is
But it's
laid.
not expressed as an angle. It's expressed as a percent grade. Okay. So how is that different from an angle? I mean, you're on the right track, definitely.
The rise over run,
Yes, it's a rise over run. So what does this telling me, Casey?
every 100 feet, it's rising. It's either rising or lowering 5.5%.
Well, 5.5 units, not
yeah.
percent. Okay. So it's saying that in 100 feet of run, it's rising or falling 100 feet vertically. Okay. Right. So look at this. We need to know what the rise is here, correct? So what we can essentially say is that 5.5 rise is to run as X amount of rise is to 250 feet of run. Because this slope has to be equal to this slope. Everybody see that? So can we solve that proportion?
Yes.
Okay, how do we solve it?
250 times 5.5 divided by 100.
All right, let's do that. So we have 5.5 times 250 divided by 100. What do you get?
13.75.
Okay, so that's your rise. So what's the invert of this point now? We're going to add that number to what?
808.32.
All right, so we're going to have 808.32 plus that. What do you get? Did you get 822.07?
Yep.
Okay, so now we've got our, we got our sewer laid out, well, we got what we need. Okay, so now I'm going to just put I'm going to do one more thing here. Let's see if I can get rid of this. I'm going to just move this down here because I want to show you what we're going to do. This is exactly what we're going to do in the field, hopefully Thursday. You know, if that doesn't work, then we'll have to do it another time, but you'll probably see this on a test. So, all right, so when you do the stakeout now, what you're going to do, when you do a stakeout, you're going to put stakes in the ground. Okay, so we're going to come over here on an offset. Whoops, let me undo that. Okay, so we're coming over here at an offset and placing a stake. We're coming over here at an offset and we're placing a stake, right? So let's say we're sitting on the ground, and let's say the ground is sitting at 8, oh, give me a minute, I gotta make some stuff up. Let's say it's 815, 70. And this stake is gonna be at 830, 33. And we're gonna place stakes along this alignment. I'm going to have one here, and I'm going to have one here. So this was 50 feet, and this is 100 feet. And give me a sec here. I want to think of something. I got to figure out something for my ground. Let's see. So we're going to call this 8/17/85. So that's the elevation of the stake. And we're going to call this 8, hold on a minute. Okay. We'll say that this guy's at 820.55. All right. So what we need to do is we need to figure out a cut, 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 and cut. Okay. So I'm going to erase some stuff here. So I'm just going to put some identification numbers up here. So this, we'll call that stake 1. Whoops. Stake 1, stake 2, stake 3, and stake 4. So we're going to put a little chart down here. Stake 1, 2, 3, and 4. So we'll first have the stake elevation. So what's the elevation of the stake 1?
815.7.
Okay, what about 2?
817.85.
Where did those numbers come from, other than the fact that I made them up? Where would they come from in the reality?
That would come from your elevations on the ground.
Not on the ground.
To the prism.
Well, you could do it if you're doing trig leveling, but if you're doing differential leveling, you got those somewhere, right? From either differential leveling or trig leveling. I guess that's my point, right? Does everybody understand that?
Yeah, they're pre-recorded.
Right, okay. So the other thing we need to know is what's the invert elevation? The invert, what does invert mean?
That would be the very bottom of the pipe.
Right, it's the lowest point of the pipe or the lowest point on the manhole. Sometimes that's referred to as flow line. Out in the field, a lot of times plumbers would call that the flow line. Okay. So for stake 1, what is the invert of that sewer? It's at what? 808.32, right?
Yep.
808.32. And the invert at stake 4 is what?
822.07.
All right, so we need to calculate the invert here and the invert here. Okay, so how do we do that?
You would use the slope gradient, and then you would use the amount of feet for each one. So
Okay.
from 808 to 0.2, you
Okay.
use 50 feet.
All right, so let's do that. We got 5.5 divided by 100, right? Times 50 gives me a rise of 2.75 plus 808.32. So it looks like this would be an invert of the pipe of 811.07. You guys verify that for me.
Yeah, that's good.
Okay, so what would be the next one? I'm gonna let you guys calculate that next one. Let's see what that next one is. I got my number.
I got 816.57.
Okay, I agree with that, 816.57. Pretty easy, isn't it? So now we just need to determine a cut, 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 and cut. So how do we do that?
It would just be the difference between the two.
Yeah, between the stake and the invert. So now normally I'm saying cut because 99% of the time, if you're putting a sewer in the ground, it's going to be a cut. Okay. Very rarely will you have a sewer go above ground. They do, that does happen, but most of the time we're looking at cuts. So for this first cut, I'm getting a cut of 7.38. You guys can verify that for me. Then 1785 minus 1107. Then I get a cut of 6.78. And then we've got, let's see, 820 minus 816. Looks like, oh, that's not very much of a cut. I had 398. Is that right? Verify those numbers for me, will you? $826. Those look right? Simply subtracting these, these. Anybody getting those numbers?
I am.
Yeah, I'm good.
Okay, so that's a sewer stakeout. Now, what we'll get to do eventually, when we get to do this out in the field, we're going to do that. You know, we're going to set up the manholes, then we'll throw the offsets in, then we'll put the stakes along it, grade it, look at our profile, figure out our cuts and fills. Okay, but you'll probably have a problem like this on the test. Okay, it's not hard to do, and we basically just went through something that's very similar. Any questions?
For the third invert elevation, I keep getting 813.82.
You might, maybe I blew it. That's why I asked you. I might have done that, Casey. I just wanted, I probably did. It's probably me. When I looked at that number, I thought, well, that doesn't look right. No, I'm getting 398.
Oh, I'm talking about for the invert elevation.
Oh, for the invert elevation?
Yeah.
Let me check mine. What do you, how are you calculating it? You're taking 5.5 divided by 100, right?
I was doing the cross multiply and divide and then adding the 802.32. And I got the same number for number 2 that you got as 811.07.
Yeah.
And then I'm getting 813.82 for the third one.
So you're saying you're taking 550 divided by 100 is equal to X over what?
I did 100 there, and I'm pulling it off of station 1. So then
No, that's incorrect.
Okay.
The distance from 3 to station 1 is not 100 feet.
It's 150. That's
It's
why.
150.
Okay.
All right.
That's why I was getting it wrong. Yeah.
Now, let me tell you this. You could take what you calculated at 100 and add it to this invert.
Okay.
You should get the same number. But I went from this one to this one using 150.
Okay. That makes sense.
Now let me say this just to show you something. If you took what you did at 100 feet and added it to this, you may not get exactly this. Do you know why?
Is it cumulative?
It's
error?
because, it's a cumulative rounding going on. Okay.
Yeah.
So you're better off going from the longer distance, okay, than adding the shorter ones sometimes. It just depends. Okay.
Mm-hmm.
But here's a nice thing out in the field. If you remember, let's say you had a pure 5% grade. Well, that's easy to calculate because that means every 100 feet I'm rising or falling 5 feet. So every 50 feet I'm rising or falling 2.5 feet. You get how easy that works.
Yeah.
Yeah. So yeah. But yeah, you just were using the wrong number if you were going from this manhole. Okay.
Mm-hmm.
If you were coming from this point, it would have worked. Okay, does that make sense? That's a really good point there. Okay.
Yeah, it does.
Because what you were doing was basically putting a kink in your pipe. Okay. If that, and you know what? That's kind of stuff you'll do out in the field too. All right. Let me ask you guys this hypothetically: Why is this getting lower and then it gets higher again? What's going on there? Can anybody tell me?
There was a dip in where you were
Yeah,
Putting
right, exactly. The ground dipped to a lower spot and then it went back up. Okay, but your slope on your pipe is what? Staying constant, correct?
Yeah.
Yeah. So you can think about that stuff logically when you see that. Okay, now when you're out in the field, it's a lot easier to see this stuff than it is doing it this way, but that's all good. It's all good. All right. That's really all I wanted to, guess we spent longer than I thought we were going to, but that's all good. Any questions anybody has?
I'm good for now.
All right, so let's talk about Thursday minute. They're talking significant rain again, but I don't want to blow anything off, okay? So let's just plan on coming in on Thursday. And we're going to try to run the lab if we can. If we can't, what I'll probably do is go over to 152 and maybe start into some highway stuff just a little bit, just go over some things. But I really, unless it's just raining buckets, I really want to try to go out, okay? So just be prepared for that. But watch Blackboard, and I'll either be sending messages or something. But I'm still planning on going in myself, okay? Any questions? No questions?
Yeah, I'm good.
All right.